DeepSeek claims its reasoning model beats OpenAI's O1 on certain benchmarks. On January 20, 2025, TechCrunch reported that the Chinese AI lab DeepSeek has claimed its reasoning model DeepSeek-R1 outperforms OpenAI's O1 model on several key benchmarks. This announcement marks a significant moment in the ongoing competition between AI developers, particularly between those in the US and China. Overview of DeepSeek-R1. DeepSeek has made DeepSeek-R1 publicly available on the AI development platform Hugging Face under an MIT license allowing for unrestricted commercial use. The model boasts an impressive 671 billion parameters, a scale that positions it among the largest AI models to date. In AI, the number of parameters is often correlated with a model's ability to solve complex problems, thus more parameters typically indicate better performance. DeepSeek-R1 has reportedly excelled in three specific benchmarks: AIM Math 500 and SWE Bench Verified. 1. AIME. This benchmark utilizes other models to evaluate performance, providing a comparative analysis of various AI systems. 2. Math 500. This consists of a series of word problems testing the model's mathematical reasoning and comprehension skills. 3. SWE Bench Verified. This benchmark focuses on programming tasks, assessing the model's ability to generate and understand code. DeepSeek-R1 distinguishes itself as a reasoning model, which means it is designed to effectively fact-check its own responses, potentially leading to higher reliability in fields such as physics, science, and mathematics. However, this self-verification process may require additional time to generate solutions compared to traditional AI models. Variants of DeepSeek-R1. Alongside the full-scale R1 model, DeepSeek has also released several distilled versions which vary in size from 1.5 billion to 70 billion parameters. The smallest variant is designed to run on standard laptops, while the full R1 model necessitates more powerful hardware. Notably, DeepSeek offers access to the full R1 through an API priced 90% to 95% lower than OpenAI's O1, making it an attractive option for developers and businesses. Regulatory challenges. Despite its promising capabilities, DeepSeek-R1 is not without limitations. As a Chinese-developed model, it is subject to stringent regulations imposed by China's internet authorities. This includes ensuring that the model's responses align with core socialist values, which means it avoids certain sensitive topics such as the Tiananmen Square protests and Taiwan sovereignty. This aspect highlights a broader trend in the development of AI systems in China, where regulatory compliance often dictates the scope of permissible content. Geopolitical context. The announcement of DeepSeek-R1 comes at a time of heightened tensions regarding AI technologies between the US and China. Just days prior, the Biden administration proposed stricter export rules for AI technologies, which could further limit Chinese companies' access to advanced semiconductor technologies. This regulatory environment aims to curtail China's ability to develop sophisticated AI systems, particularly as US companies like OpenAI express concern over the potential for Chinese models to catch up or even surpass their capabilities. In response to the competitive landscape, OpenAI has urged the US government to bolster domestic AI development to maintain a technological edge. In a recent policy document, OpenAI highlighted concerns regarding organizations like High Flyer Capital Management, DeepSeek's corporate parent, as a particular focus for future regulatory scrutiny. Industry reactions. The emergence of DeepSeek-R1 has drawn attention from various AI researchers and industry experts. Dean Ball, an AI researcher at George Mason University, noted in a social media post that the performance of DeepSeek's distilled models indicates a trend toward the proliferation of capable reasoning models that can operate on local hardware. This accessibility could pose challenges for regulatory oversight as these models become more widely used outside of direct governmental control. DeepSeek is not alone in this competitive arena. At least two other Chinese labs, Alibaba and Kimi, a subsidiary of Moonshot AI, have also claimed to have developed models that rival OpenAI's O1. However, DeepSeek was the first to announce a preview of its R1 model, indicating its proactive stance in the market. Conclusion: DeepSeek's announcement regarding its R1 model marks a pivotal moment in the AI landscape, particularly in the context of US-China relations. The model's performance on critical benchmarks raises important questions about the future of AI development and the geopolitical implications of technological advancements. As AI continues to evolve, the balance of power in this field may shift, influenced by regulatory environments, market dynamics, and the capabilities of emerging models like DeepSeek-R1. DeepSeek's claim that its reasoning model DeepSeek-R1 outperforms OpenAI's O1 model on specific benchmarks raises several counterintuitive points worth exploring. 1. Parameter quantity versus performance. Traditionally, the performance of AI models has been closely linked to the number of parameters they possess. DeepSeek-R1 boasts an impressive 671 billion parameters, significantly larger than many models available today. However, the counterintuitive aspect here is that merely having a higher number of parameters does not guarantee superior performance across all tasks. While DeepSeek claims that R1 outperforms O1 on particular benchmarks, this suggests that other factors, such as the model's architecture, training data, and fine-tuning methods, could also play critical roles in its effectiveness. The implication is that smaller models, or those with fewer parameters, may still excel in specific contexts, challenging the assumption that bigger is always better in AI. 2. Reasoning versus speed. DeepSeek's R1 is characterized as a reasoning model, which inherently means it may take longer to arrive at solutions compared to traditional models. The longer processing time might initially seem like a disadvantage, yet the model's ability to fact-check and provide more reliable answers in complex domains like physics, science, and mathematics can be seen as a significant advantage. This counters the common perception that faster responses are always preferable, emphasizing the value of accuracy and reliability over speed in certain applications. 3. Open source and accessibility. DeepSeek has made R1 available on the Hugging Face platform under an MIT license, allowing for commercial use without restrictions. This contrasts with the typical narrative surrounding advanced AI models, which often come with significant usage fees and access limitations. The availability of distilled versions of R1 which can run on less powerful hardware like laptops challenges the notion that only large corporations with high-end infrastructure can utilize cutting-edge AI technology. This could democratize access to advanced AI capabilities, allowing smaller developers and researchers to leverage powerful tools that were previously out of reach. 4. Censorship and model limitations. A significant limitation of the R1 model is its compliance with Chinese internet regulations, which restricts its ability to engage with sensitive political topics. While this is a common feature of many Chinese AI systems, it raises the question of how much this restriction affects the model's overall utility and acceptance in the global market. This limitation might lead to the perception that R1 is less versatile than its competitors despite its performance on technical benchmarks. The counterintuitive takeaway is that a model can achieve high performance metrics while simultaneously being constrained in its applicability due to regulatory oversight. 5. Implications of international competition. The release of DeepSeek-R1 comes at a time of heightened scrutiny and regulation concerning AI technologies, particularly regarding national security and technological competition between the US and China. OpenAI's call for US government support to prevent Chinese models from catching up in capability illustrates a paradox. While competition may drive innovation, it also fosters an environment of fear and limitation where companies are pressured to prioritize performance over ethical considerations. This situation suggests that the race to develop superior AI may lead to unintended consequences, such as the proliferation of models with restricted capabilities that could hinder broader advancements in the field. 6. Market dynamics. The mention of DeepSeek's ability to offer its model at significantly lower prices than OpenAI raises questions about the sustainability of such pricing strategies in the long term. While lower costs may attract users, they may also lead to a devaluation of AI services, impacting the business models of firms like OpenAI that rely on subscription revenue. This dynamic challenges the traditional view that high-quality AI must come with a high price tag, suggesting that competitive pressures could reshape the market landscape in unexpected ways. In conclusion, DeepSeek's announcement presents a multifaceted view of the current AI landscape, where performance metrics, model architecture, regulatory environments, and market dynamics intersect in complex ways. The situation illustrates that advancements in AI are not merely about technical prowess but also involve navigating a landscape shaped by ethical, regulatory, and competitive factors. DeepSeek's announcement that its reasoning model DeepSeek-R1 outperforms OpenAI's O1 on certain benchmarks has significant implications in the realm of AI development, particularly in the context of international competition and technological capabilities. While many aspects of this report may initially seem straightforward, several critical elements warrant deeper examination. Key details often overlooked. 1. Impact of parameter count. The total number of parameters in DeepSeek-R1, 671 billion, is a notable selling point. This sheer scale is important because parameter counts often correlate with a model's capacity to learn and generalize from data. However, it's crucial to consider the diminishing returns of adding parameters. More parameters can lead to increased computational requirements and potential overfitting. The significance here lies in the balance between model size efficiency and actual performance on real-world tasks, which may not always align. 2. Distilled versions of R1. DeepSeek's release of distilled versions of R1 ranging from 1.5 billion to 70 billion parameters allows for broader accessibility and application. Many may focus solely on the largest model, overlooking the implications of these smaller versions. The ability for users to run capable AI models on local hardware represents a shift in accessibility and democratization of AI technology. This could lead to increased adoption of AI across various sectors, particularly in regions or organizations with limited access to high-performance computing resources. 3. Regulatory constraints and their influence. The report highlights that DeepSeek-R1 is subject to Chinese internet regulations, which restrict certain topics. This filtering mechanism is significant not only for understanding the model's limitations but also for recognizing how such constraints shape AI capabilities and user trust. Users may be unaware of the extent to which regulatory influences can affect the outputs of AI systems, which could lead to skewed perceptions of their reliability and applicability in sensitive domains. 4. Geopolitical context. The timing of the DeepSeek-R1 release following proposed stricter export rules from the Biden administration regarding AI technologies for Chinese ventures is highly significant. This context underscores the strategic importance of AI development in global politics. The race to develop competitive AI technologies is not just about technological prowess, it also involves national security, economic competitiveness, and international relations. The emergence of DeepSeek and similar entities reflects a broader trend of nations investing heavily in AI as a critical infrastructure. 5. Response to American AI models. The claim that DeepSeek's models can compete with OpenAI's O1 indicates a shift in the landscape of AI development. While many may view this as a simple competitive claim, it suggests a larger movement where Chinese AI labs are not merely imitating Western models but are rapidly advancing their capabilities. Dean Ball's comments about Chinese labs as fast followers hints at a transformative phase where these labs may soon lead in certain areas of AI research and application. Significance of the findings. The implications of DeepSeek's advancements extend beyond simple benchmarks. The ability of R1 to outperform O1 in specific areas suggests that the gap between AI capabilities in the East and West may be narrowing. This could lead to increased investment in AI research and development worldwide as nations strive to maintain or achieve technological superiority. Moreover, the presence of distilled models that can operate on less powerful hardware signifies a potential shift in how AI technologies are deployed. This could democratize access to advanced reasoning models, fostering innovation in smaller enterprises and developing nations that may not have the resources to access high-end computing facilities. The regulatory landscape surrounding DeepSeek-R1 serves as a reminder of the ethical and political dimensions of AI technology. As AI models become more powerful, the implications of their deployment in societies with strict regulatory frameworks could lead to significant ethical dilemmas regarding freedom of expression, data privacy, and the potential for state surveillance. In conclusion, while the performance metrics of DeepSeek-R1 relative to OpenAI's O1 are noteworthy, the broader context of its release, the implications of its parameter count, the presence of distilled models, and the geopolitical dynamics surrounding AI development are equally significant. These elements collectively shape the future of AI technology and its role within global socio-political structures. 1. Performance benchmarking against OpenAI's O1. DeepSeek's R1 model has demonstrated superior performance compared to OpenAI's O1 on specific benchmarks, namely AIM Math 500 and SWE Bench Verified. This highlights a significant advancement in AI capabilities, particularly in reasoning tasks where R1's self-fact-checking ability allows it to provide more reliable solutions in complex domains like math and programming. The competitive edge may influence the AI landscape by pushing other organizations to enhance their models to maintain relevance. 2. Scale and accessibility of AI models. The R1 model boasts an impressive 671 billion parameters, positioning it among the largest AI models currently available. This substantial scale is correlated with improved problem-solving capabilities. Moreover, DeepSeek's strategy of releasing distilled versions of R1 ranging from 1.5 billion to 70 billion parameters facilitates accessibility, enabling deployment on local hardware including laptops. This democratization of AI technology could accelerate innovation and application across various sectors. 3. Regulatory constraints and content filtering. Being a Chinese-developed model, R1 is subject to the stringent content regulations imposed by China's internet authorities, which limit its responses on sensitive political topics. This limitation raises important discussions around censorship, freedom of information, and the implications of governmental oversight on AI technologies. It also draws attention to the challenges faced by AI developers in balancing performance with regulatory compliance, particularly in politically sensitive environments. For a geopolitical context and international competition, the release of DeepSeek's R1 comes amid heightened scrutiny of Chinese AI capabilities by the U.S. government, including proposed export restrictions on AI technologies. This geopolitical tension underscores a broader narrative of technological rivalry between the US and China, with implications for global AI development. The emergence of competitive models like R1 may compel organizations like OpenAI to innovate rapidly and may influence policy decisions regarding AI research and export controls. Reflecting the strategic importance of AI in national security and economic competitiveness. 1. The Wright brothers versus Glenn Curtiss. Early aviation development. In the early 20th century, the Wright brothers Orville and Wilbur made significant advancements in aviation technology with their development of the first successful powered aircraft, the Wright Flyer, in 1903. However, Glenn Curtiss, a rival aviation pioneer, developed his own aircraft designs and engines that were based on different principles and capabilities. The competition between these innovators led to various aviation breakthroughs and patents, ultimately shaping the future of flight. This rivalry can be compared to the ongoing competition between AI companies, where different models and approaches vie for supremacy in performance benchmarks. 2. Tesla versus traditional automakers. Electric vehicle market. Tesla's introduction of electric vehicles (EVs) disrupted the automotive industry, compelling traditional manufacturers to accelerate their own EV development. Tesla's innovative technology and software integration outpaced many established companies, at first leading to a competitive landscape where legacy automakers had to adapt or risk obsolescence. Similarly, DeepSeek's claims about outperforming OpenAI's model on specific benchmarks illustrate the competitive dynamics in the AI sector where new entrants challenge established leaders to innovate and improve. 3. IBM Watson vs. Google DeepMind AI in healthcare and games. IBM's Watson gained fame for its performance in the quiz show Jeopardy! And its subsequent applications in healthcare where it was used to assist in diagnosing diseases and suggesting treatments. Meanwhile, Google DeepMind's AlphaGo demonstrated the capabilities of AI in mastering complex games like Go, defeating world champions in the process. Both entities represent significant advancements in AI, but also highlight the competition within the field as they push the boundaries of what artificial intelligence can achieve in different domains. Much like DeepSeek's recent performance claims against OpenAI, this ongoing rivalry emphasizes the importance of benchmarks and capabilities in the AI landscape. The recent announcement from DeepSeek about its reasoning model DeepSeek-R1 claiming superiority over OpenAI's O1 on specific benchmarks marks a significant moment in the rapidly evolving landscape of artificial intelligence AI. With a massive 671 billion parameters, R1 has demonstrated impressive performance in tests such as AIM Math 500 and SWE Bench Verified. This situation raises several important predictions for the future of AI development, competition, and regulation. 1. Increased competition in AI models. The emergence of DeepSeek-R1 signifies an intensifying competition in the AI space, particularly between Chinese and Western companies. As more Chinese labs like Alibaba and Kimi Moonshot AI announce competitive models, we can expect a race to innovate and improve model capabilities. This will likely lead to the development of even more sophisticated models as organizations strive to outperform each other in benchmarks and real-world applications. The competition will not only be in terms of performance but also in terms of accessibility and cost. 2. Diversity of AI applications. With models like DeepSeek-R1 becoming available on platforms such as Hugging Face, the accessibility of advanced AI technologies will increase. This democratization of AI could spur innovations across multiple sectors including education, healthcare, and software development. Smaller companies and individual developers will have the opportunity to leverage these powerful tools without the need for extensive resources. As a result, we could see a surge in creative applications from automated tutoring systems to advanced coding assistants. 3. Regulatory challenges and responses. DeepSeek-R1's compliance with Chinese internet regulations, including restrictions on sensitive topics, underscores the complexity of AI deployment in different geopolitical contexts. As AI models become more prevalent, regulatory frameworks will need to evolve. In the West, particularly under U.S. scrutiny, AI companies may face increased pressure to ensure ethical AI use and transparency. This could result in divergent paths for AI development, with Chinese models adhering to strict political guidelines while Western models might focus on ethical considerations and user privacy. 4. Technological decoupling and national security concerns. As the U.S. government proposes stricter regulations on AI exports to China, the landscape of AI technology may become increasingly fragmented. The potential for a technological decoupling could lead to two separate ecosystems, one dominated by Western technologies and another by Chinese innovations. This bifurcation may hinder collaboration and knowledge sharing, which could slow down the overall progress of AI research. In response, governments may invest more in domestic AI capabilities to maintain competitiveness. 5. Shift towards localized AI solutions. The introduction of smaller distilled versions of DeepSeek-R1 that can run on consumer-grade hardware suggests a trend toward localized AI solutions. As these models become more capable and accessible, there may be a shift away from reliance on centralized AI systems that require significant cloud infrastructure. Localized models can provide users with greater control over their data and applications while also reducing latency and improving user experience. This trend could also align with privacy concerns, as users prefer solutions that minimize data sharing with external entities. 6. Advancements in reasoning and self-correction mechanisms. The focus on reasoning models like DeepSeek-R1 indicates a future where AI systems not only generate responses but also enhance their reliability through self-correction mechanisms. This capability is crucial for applications that require high accuracy, such as scientific research and technical problem solving. As more AI models incorporate reasoning abilities, we can expect improvements in fields that rely heavily on logical deduction and complex problem solving, leading to breakthroughs in areas such as mathematics, physics, and engineering. 7. Ethical considerations and AI governance. The rise of powerful AI models also brings ethical questions regarding their use and governance. As AI becomes more integrated into daily life and decision-making processes, issues around bias, accountability, and transparency will gain prominence. Future developments will likely involve creating frameworks for ethical AI use, with stakeholders from government, academia, and industry collaborating to establish guidelines that ensure AI technologies serve the public good while minimizing harm. Conclusion. The announcement of DeepSeek-R1 and its claimed superiority over OpenAI's O1 is a pivotal moment in AI development, reflecting broader trends in competition, regulation, and technological innovation. As we look to the future, the AI landscape will be shaped by the interplay of these factors, leading to both opportunities and challenges. Stakeholders must navigate these dynamics thoughtfully to harness the potential of AI while addressing the ethical and regulatory implications that come with its rapid advancement.